So what I've done here is I've opened up a second window so that we can work with the appended matrix right next to where we had the original matrix. What I want you to do is copy over this appended system, solve the linear system using the appended system, and then come back and check if you did the right thing. And go ahead and do that now. So I've gone ahead and copied over the appended system from the web page. And what we're going to do now is go through exactly the same steps as we did with the equations, except now with the appended systems. So again, we need to do row 2 minus something times row 1, and row 3 minus something times row 1. And what is that going to be? Well, just like before, we compute the multiplier by looking at this divided by that. So that gives us a 3. And we might as well go ahead and compute the multiplier for this right here. And that becomes 1. Now, what is then the next step? If we take 3 times the first row and subtract it off the second row, then we get our first row right back. But the second row now gets a 0 right there. Minus 3 plus 1 is minus 2. Minus 6 plus 7 is 1. And minus 3 times minus 1 is positive 3. Minus 7 is minus 4. And then this minus that is 0. This minus that is 6. This minus that is minus 1. This minus that is 8. And then we need to do row 3 minus something times row 1. And what is that something? It's this divided by that. That's our multiplier. 6 divided by minus 2. And of course that's minus 3. So the final thing we get is this right here. And then this has to become a 0. That's the whole purpose. And now we get 3 times that added to that gives us a 2. And 3 times that added to that gives us a 12. And whoops, let's see, I forgot to copy these over. And there we have it. And now we recognize that this is just the last equation. The last row here represents 2 times chi2 equal to, oh, this is all wrong. This is 3 times that is minus 12 plus 8 is positive 4. So this we get, oh, it's minus 4. Boy, I'm really being sloppy. And then chi2 is obviously equal to minus 2. And then you look at the second row, and that represents minus 2 times chi1 plus chi2 is equal to minus 4. And of course we know that chi2 is equal to minus 2. So therefore we get that chi1 is equal to minus 4 plus 2 divided by minus 2. And that's equal to positive 1. And then finally we get that this first row represents chi0 plus chi1 plus 2 times chi2 is equal to minus 1. And that we know that chi1 is equal to 1, and we know that chi2 is equal to minus 2, and therefore we get that chi0 is equal to minus 1 plus 4, which is equal to 2. So our solution vector is chi0, chi1, chi2. Whoops, I went way off the thing. Anyway, I'll put that up there, is equal to 2, 1 minus 2, which is the same solution as we got when we used linear systems, or actual linear equations, as opposed to the appended system. All right. Okay, so now you have done everything by hand. You can now plug in the multipliers that you computed right here and see if you got the right steps along the way. And notice that it's important to compare what's on the left here to the right. Exactly the same numbers come out. We have just written them as an appended system as opposed to with the full equations. So then we put the second multiplier in, or the third multiplier, and we end up with this system of linear equations represented as an appended system, and then we can go and perform our back substitution and reveal the solution.